Roxanne is currently the Executive Director of the Florida Onsite Wastewater Association. She holds an engineering degree from Old Dominion University, and in her spare time is attempting to work on her graduate degree. She wears various hats in the Florida Onsite Water Association by coordinating and teaching continuing education, outreach to community regarding on-site wastewater treatment systems, running a not-for-profit association, and staying extremely active in the politics that affect her industry. Ladies and gentlemen, Ms. Roxanne Groover. Thank you, ma'am.
All right, thank you. So thank you for inviting me to talk to you. My background is in engineering and my PhD project is finished. I just haven't written my dissertation. So, and that is on nitrogen reducing technologies using media filters. And I come from Virginia, so the Chesapeake Bay Foundation. So thank you for allowing me to be here. And what we're going to talk about today isn't those legacy systems. We're going to talk about the options that we have. And I think what happens is there's a lot of possible misinformation or just not correct information or just not information out there as it relates to the different types of systems. So when you think of a conventional or a legacy system, you're thinking of a septic tank along with your drain field. And when those were originally designed, a long time ago, we were just looking to control fecals, so your distance from your well, so you weren't drinking poo water. And then they would do some BOD and TSS, so biochemical oxygen demand and total suspended solids reductions. These conventional systems were not designed to take care of nitrogen. We weren't looking at that. We probably should have been. The Chesapeake Bay we've been looking at for 20 plus years. Florida's just been a little slower. But I think part of the information that's out there, or the misinformation, is that these are new. These have been around, ATUs have been around since the 1950s. Nitrogen reduction systems we've been looking at since the early 90s. So these aren't new. What the challenge is always going to be is, as Vincent said, as long as that homeowner can sit on their toilet and flush that toilet, they think their system is working. It might be working as the flow flows away, but it might not be taking care of the contaminants that we're worried about. So we have the ability on on-site systems to treat nitrogen. It's just we haven't been allowed, I guess is the best thing, in a state to move them forward because there is going to be a cost with that. And one of the things that I always find very interesting, and Vincent, you did a great job, and I didn't have to do any of that, all the details, so thank you so much for that. That was great. We don't get the funding. So you as a homeowner that's going to upgrade to one of these on-site systems doesn't get that same funding. And I think part of that challenge is we often don't recognize that these can be a permanent infrastructure change. So when you look at the EPA and you look at the EPA draft reports, they tell you that they are part of this permanent infrastructure that communities such as yourself need to look because you can't bring the municipal plants everywhere. And so in certain areas, you want to have the availability, but what causes the challenge is the funding initiative. Because let's all be honest, how many of us could stroke a check for $2,000 today and not have to worry about something else going by the byway? Typically, it doesn't happen. And so that funding initiative. So we're going to take away and not talk about funding. We're not going to talk about legacy. What we're going to talk about is all the options that we have available out there that have been tried and tested for 20 plus years that you have to use for nitrogen reduction systems. So an OSTDS, and I heard Vincent say this a lot, it's an on-site sewage treatment and a disposal system. So we are truly now talking about systems that do treatment. What do we treat? BODs, TSSs, fecals, why we don't want our beaches to be closed, and then nitrogen and phosphorus. So depending on what kind of technology you want to look at, what level of treatment you want to look at, we have lots of different options. And so once again, what I'd like you to come away with from this discussion is there are options, of viable options out there, we just typically don't use them. And so the different types that we have are aerobic treatment units, And when you come to the state of Florida, it's not like Roxanne can just go into her backyard and invent Roxanne's Poo Guru and use that as a system. So we take aerobic treatment units through 2 different independent standards. There's NSF 40, and then there's NSF 245. And when we talk about an NSF 245 system, this is third-party testing, and what the 245 is, now we're talking about nutrients, and the nutrient we are talking about is nitrogen. So that becomes a crucial element for communities such as yourself when you want to remove that portion of your wastewater stream. We have performance-based treatment systems, and those came about when we started talking about the Florida Keys. In fact, we have Mark the engineer back there. Mark waved to everybody. And Mark did a lot of systems down in the Florida Keys. And so what we realized is that's a very important part of our state. And so 20 plus years ago, they said, well, we need to start thinking about nitrogen and phosphorus and everything that goes with it. So we had the development of these performance-based treatment systems. So they've actually been in our code language for quite a long period of time. And then we have the Florida Key standards, which we were just talking about. And then we're going to talk a little bit about these in-ground nitrogen-reducing biofilters. I've already been asked about those. I could spend all night. We could be here till 7 o'clock tomorrow morning going into detail. So I'm going to give you a fast overview and then pull me aside afterwards, and we will talk about these systems that you need to talk about. And probably the biggest one that I have a lot of people have a lot of questions about is this INRB, or these in-ground nitrogen-reducing biofilters. Vincent, I see what you're saying. Standing still is very hard, right? Very, very hard. So aerobic treatment units, they were originally designed, like I said, back in the 50s. And what everybody was talking about is, I need better treatment. I need better treatment. Because a conventional septic tank, what it does is you put your solids in there, right? We flush the toilet. The solids go in there. We give it enough time. They settle out. Then we have the wastewater that comes out, and it goes into our drain field. Well, in a conventional system, that legacy system, that drain field has to do all the work. And we realized in the state of Florida, sometimes we want to build big homes on little tiny lots, right? And so we needed more. And so an ATU is basically a miniature version of a wastewater treatment plant. So you have aeration going on, you have settling going on, you could have recirculation going on. But what you've done is now when it goes out to the soils become your dispersal mechanism. So you don't have to worry about how high your BODs are and TSSs. So is my drain field getting clogged? That's the bottom line. How long is my system going to last? Is my drain field getting clogged? And within those, you have a couple of different categories. So you have the suspended. So it means the little bugs are hanging out, swimming around in there and doing their business. You have fixed film. So now we've put something inside. And when you guys were out there, hopefully looking at those different systems, you saw that we have some fixed film systems out there. So basically what that means is 2-family home, we're all working, we come in Saturday, we throw all the laundry in, we go out to the games with the kids and all the kinds of stuff, we come back and we throw more laundry in. That little bug can just hold in there and do what it needs to do and not get washed away. Or if we're a snowbird, that little bug can hang in there and move around during low flow times. And so you see those types of systems. And then you have unsaturated media filters. So you have a group of proprietary filters that use different kinds of material, and we're going to see pictures of them, that operate very similar, but it's not submerged. So we don't want them saturated. So this is a very busy chart, but it does a couple of things. It talks about the level of treatment. So you see the title, Performance-Based Treatment Systems. And there's 2 reasons we use this. The first one is we want to look at the level of treatment. That's important. One of the nice things about on-site systems is it's not a one-size-fits-all. You might have a community with 40 different systems, but because of the layout of the land, how you've situated your house, where your water body is, different things that you want to do, different levels of treatment, you can use this chart and design a system and have a system designed for you that's going to meet those treatment standards. If you could look under that black line, and I'll make sure we get things to you to put on your site so you could actually read this chart, you'll see the advantages. And what happens is as you get better treatment, the state allows you certain allowances. And those allowances are flow increases, setbacks. We do not ever mess with vertical separations. One of the things Vincent said was very true. When we started way back when, you could get very, very close to your seasonal high water table. And in some areas, you were at 6 inches. We now require a minimum of 2 foot of vertical separation. So what that means is we know we need good soils. We know we need good soils. If we're not going to have good soils, then we need that treatment up front. Hence, you're going to use one of these kinds of systems. This is the Florida Key Standards. Once again, a very delicate area, so now we're talking higher treatment standards. So a secondary wastewater treatment plant, not an advanced wastewater treatment plant. And then we're also talking nitrogen standards and phosphorus standards. The Florida Keys were one of the only areas in the state that we as on-site folks could actually use injection wells. The state of Florida, one of the things that we do is we always go subsurface. So what that means is no matter what your treatment is up front, you're always going to use the soils. So they're either going to be a treatment or they're going to be a polisher. So the one slide I'll have to tell you, Vincent, I had a little challenge with is the directness of 30 so many homes and things like that. That didn't account for any treatment even in a most basic system. And if you look at that same study you were referencing, they talked about a reduction of 50%. So we didn't get you, in that slide, we didn't see that reduction. So that's just one of those things that happen. Now, 50% reduction would have to be a perfect situation. There's never a perfect situation. It works great on paper. You get it out there in the field. So I'm not going to tell you we get a 50% reduction. I'm not going to tell you that at all. But what I am going to tell you is what you sit down on the toilet and send out is not going to be the same thing that's going to hit that waterway from an on-site system. And that's what that slide showed. So this is some of the criteria. We have a lot of people that I think don't understand how rigorous the testing is. So I sit on the NSF Joint Committee. It's a wastewater committee. And we develop third-party testing data, rules and regulations and standards that people have to follow. And the nice thing about it, it's truly controlled. So you're an apple, and not only are you an apple, you're a Macintosh apple. So what happens is Roxanne invents Roxanne's Poo Guru. I send it out to NSF Standard 40, and while it's being tested over that 6-month period, I don't come back and I don't do anything else. I don't do anything with it. And that's one of the reasons, if anybody does anybody in the room have an ATU or performance-based treatment system? Does anybody have on-site systems? So we have everybody here that's on central sewer? You have an on-site system? 2. Are they conventional? You got to back up. All right. It's always interesting that we miss the on-site people in these meetings, and it's always the Seward folks that show up. But what happens is the effluent goes in, we test it for the different parameters up here, and then in order for them to pass that standard, they have to consistently meet the requirements here. And so this is a basic ATU system, and if you look up there, you see that they don't really talk about fecals, they don't talk about nitrogen, they don't talk about phosphorus, but it allows us to do better treatment. And so when you look at those systems that have been tested and currently approved, we have 25 systems that are available for the use. Now, the interesting thing is in most of these 25 systems, you could do some mechanisms, just like a wastewater treatment plant would do, to make their treatment even better. So this gives us 25 options to start that first step above those legacy systems. And once again, it's not a one-size-fits-all, and that's part of the beauty of on-site. I can meet your needs at your site, and I don't have to worry about what your neighbor does. So these are some of the different suspended ATUs and performance-based treatment systems. One of the things with this presentation is it should link. So what we like to have the availability for you to do is to go to each one of these manufactured sites and look. Hopefully we all have some tools in our toolboxes and they're not all just hammers. So what this does is it gives you the pliers and the different kinds of screwdrivers and things like that. So you can go out and look at the different technologies that you have available. So you can see there's just a lot of technologies that we have out there that are going to meet some of your needs. I'm going to step away. I think I can yell. This is a small group. So these are suspended. And like I told you, suspended means that my bugs are mixing. So an aerobic treatment unit is going to have some mechanism for air. You can't hear me this way? I don't know if I can get this on. Maybe if I just hold it. If I hold it, no? Yes? You can hear me? Yeah? Okay, let's do it this way. I have earrings and hair, so it didn't work as well as it did for Vincent. Sorry, now we're really awake. So on a suspended system, what happens is we have mixing in there. And so that mixing is where the bug population, it's not going to work that way either. That's all right, we'll do fine. So in the blue areas that you see, that's the mixing. That's where you had the bug population build up. Why do we care about the bug population build up? That's where we get the treatment, because most of domestic waste is organic waste, so we can break it down. We can't break down the sand and the lint, but we can break down what we need to break down. Then we have these fixed film systems, and so these are the ones that we have media that's down and saturated into the tank, but it also has mixing. So on these, there's different things that you can have. You can have membranes, you can have socks. You see the one that looks like socks. You can have little tiny balls and things like that. If you looked at those technologies out there, one of the things that makes them different was the type of media they had in their tanks for those saturated zones. So how we get the air in there, but also the media. And like I said, one of the benefits to these kinds of systems is if you get a high flow, they're not pushing that bug population, because if I don't have that bug population, I don't get the work done that I need. And during low flows, some of those bugs are mobile, so they can move around. So these work extremely well in high flows, low flows, high strength waste situations. All right, so and then the other one we have is what we call proprietary. And the reason we talk about proprietary versus non-proprietary is I'm going to talk to you about this INRB, and it's non-proprietary. So it means you can hire a contractor that can come out and build this system for you. But these proprietary ones, we have both the natural medias and we have the artificial medias. And so with those, what they do is they sort of behave like your soils do out in your drain field. Is we're going to hit them with the waste. It's going to percolate down through that media. That media is where your bug population develops, and then you get that treatment of those organics through there. And so in the state of Florida, we have 3 that use peat and 1 that uses coconut coir. And then you have your artificial media systems. And so in those cases, these are typically byproduct reuse, and it's going to be the same kind of mechanism. We're going to put the wastewater in, it's just going to move through an artificial media instead of a natural media. Then we have where you really want to be with your discussion is this NSF 245 criteria. And what happened is 25 years ago, Chesapeake Bay was really having a lot of challenges. And so ETV was developed, and through a grant program with the EPA program, and they said, we're concerned about nitrogen, let's look at nitrogen. And so they developed this ETV. ETV is a little bit different. As a manufacturer, you could come in every day and do different things to your system. It was more of a, does this work kind of system, not can we certify it. Then NSF developed the 245 protocol. So what the 245 protocol does is, once again, 6 months, you not touching it, and then we see what it does. To meet the criteria of an NSF 245, you only have to have a 50% reduction. One of the things that's crucial, and one of the reasons I'd like you to click on some of those links, is because a lot of these systems did much better. We have systems that might only do a 50.8% reduction. We also have systems that do in excess of 80% reduction of nitrogen. And I think that's what people miss. So out of the end of the pipe, we do almost 80% reduction. Then we put it in the soil, and it has further reductions. And that's where that 30 pounds starts going away. Nobody ever gets to 0. It doesn't happen. But there's a big difference between not treating a lot of nitrogen at the end of the pipe at that septic tank, running it into one of these 245 systems, getting almost an 80% reduction, taking it to the soils, and getting further reduction. And so that's one of the things I think where we have some misinformation is that we do have those technologies out there. So we have ones that far exceed this standard. And you just have to click on those links and go and look and see which ones do the treatment levels. So these are all the different 245s. One of the things that's very interesting in the state of Florida is, so we accept these standards from NSF, but the state of Florida goes a little bit further. And one of the reasons we go a little bit further is we have extremely high seasonal water tables. And so when a technology comes to the state, because one of the things you'll find out is not every NSF 245 system that's been approved is here in the state of Florida. And one of the reasons they aren't is it's not because the technology doesn't meet the needs. They haven't gone ahead and done their tank testing protocol. So the state of Florida has a mandatory tank testing protocol. So anything we're going to put in the ground, you have to make sure it will handle being put in a seasonal high water table and deal with the fluctuations that we have inside our soil. So that's something we do above and beyond because we realize how important it is for the structural integrity of these tanks. Then we have the non-proprietary. So has anybody heard of the layer cake systems, in-ground systems, mulch systems? Nobody? Okay. Usually I have a few. One of y'all did because you asked me about it. All right, so this is an in-ground nitrogen-reducing biofilter. They call it the INRB. So a little history on these systems. Several years ago, the legislative body put aside about $5 million. And what that was to do was to look at technologies that would be available and develop non-proprietary technologies that folks could use that would be more of what we call a passive system. So the other ones that you were looking at, in some way or means, use some type of electricity. Now, one of the things I want to tell you is they don't use a lot of electricity. Most of them are about 30 cents a day. So it's not, that's one of the things we hear a lot is, oh, I don't want these. What are we going to do when the power goes off? Same thing that the wastewater treatment plant is going to do when the power goes off. You have options, and you typically stop doing a lot of your water things when you don't have power. You're more worried about what caused you to lose your power. And I want you guys to think, how many times a year do you lose your power, and how long do you lose your power? But part of this discussion up at the legislative body was, how can we put in these passive systems? So what happened is there was a development. It was part of the Fosner study. You can go on the Department of Health webpage, and this link will be in my presentation also, and you can look at the system. The system you're looking at here wasn't developed in that Posner study. There was some patent infringement stuff that went on, and so the one we ended up putting in our code book right now, and we're working on adding some new ones, is a DEP study. So this one was funded by the DEP in Itchinatuckney, and it was in the home of the forest ranger up there. And so what this does is it does just like a media filter, but it uses different layers. So that little top black layer right there is your drain field. So what we're used to seeing as a drain field, that's what you have. Then that more orange layer, well, yellowish layer, mustard layer, is a nitrifying layer. So that's what the sands are that we think so much about. We don't get a lot of treatment in the sands, but there are very high air concentration. So what happens is the ammonia that's coming out of your toilet goes through these stations, and now it becomes nitrate. Nitrate's the one we don't like, right? So then that orange layer is what we call the media aggregate mix. And so what that is it's typically some kind of wood mulch. We bring in an aggregate because wastewater will go through the path of least resistance. So by adding some sandier soils in there, we'll actually get our wastewater through our mulch, and that's where we get our denitrification. And so this is that passive system. And depending on where your seasonal high water table is, that might be just base with your ground where you wouldn't realize that you had a nitrogen reducing system, or it might be mounded up. These can't be used in every area. They do have to have vertical separation, so we tend to call these our high and dry systems. But this is that passive, non-proprietary system that your septic tank contractor can go out and source the materials, and he's not necessarily buying Roxanne's Poo Guru. They're going to be regulated the same way as a conventional drain field is. The thing that's going to be a little different is there's an extra inspection protocol that has to go on. So that DOH person is going to come out, and you're going to obviously put that orange layer in first, so the DOH inspector is going to come out and make sure you did that properly, make sure you have your vertical separation. The other thing is you have to tie this to the deed of your house. And the reason you have to do that is because these look like conventional systems, and if you sell your house, we want the next person to know that they now have a nitrogen-reducing system. They don't just have a conventional drain field, because a lot of times, out of sight, out of mind, and so we want to make sure that that new homeowner understands that they have a nitrogen-reducing drain field. So we sort of talked about these. So with all of these together, you have in excess of 30 different systems that you can use. So we have lots of opportunities out there to do that. Some of the ways it makes it easier, you can go actually on the Department of Health at this link. You can pull up all these different technologies that I talked about. We will make sure we get a little QR book to you that makes it easy to scan. I like QR codes, and that way I don't have to worry that I typed the wrong web search in there. I came out of Colorado, I apologize. At 3:30 this morning, I was in Loveland, California, or Loveland, Colorado for a convention, and I apparently left all my paperwork instead of in my car in my offices. So when you go to that DOH website, you'll see these links. So you'll see the ATUs, you'll see whether they're NSF 245, you'll see whether they do nitrogen, you'll see the level of nitrogen treatment they do, so you can pick the one that meets your situation best. This is the big one, and I started off with this, is how do we address the cost? This is probably the biggest challenge we as an industry, you as homeowners have, is we still don't have the entire funding mechanism in place for a single family home. One of the things you can do is you can also cluster these, and I've got a slide that talks about that. So we have been working with communities. A community can request the money instead of requesting it for upgrades to their wastewater treatment plant. They can request the money to do upgrades to the septic systems, and so they're on-site systems. And we have several of those projects going on right now. So there's the springs restoration. Part of the challenge with the springs restoration funding is it's very, very specific to the springs, but that's because that pot of money has been put aside. But there are areas that are covered in that. We certainly would encourage you to reach out to your House and your Senate members and ask why you aren't part of this funding and how could you be part of funding. We can't pull it from the Springs Fund, but there's other ways to do this. One of the nice things they do have in some of these communities is this financial assistance. So I like to call them first adopters. So what has happened now, I don't know how aware you guys are all with all the BMAPs that are going on. The only thing that's enforceable in a BMAP right now is new construction of an OSTDS in a primary focus area on a house less than 1 acre. Ballpark, what does that mean? If you've got more than 1 acre or you're not in a primary focus area, you are still putting in a conventional system in an area we have determined that we have nitrogen concerns. But that's just how the BMAP was written. And so what has happened is the DEP has come up with $7 million in these very specific counties, these 9 counties. And if you come in today to get a repair permit or a modification, they will give you a $10,000 incentive to get you to upgrade and go ahead and do that nitrogen reducing system. So instead of putting your conventional system in that by law you could do today, they will give you that $10,000. Sometimes it covers the whole cost. Sometimes it only covers part of the cost. But you can now upgrade and know that you've done the right thing, that you've addressed the nitrogen contamination coming from your system versus just putting in a conventional. And they're not going to address those till at least year 5. And then, like I said, this decentralized concept, and this is where I came from the engineering world. I did probably more decentralized than single-family homes. So new construction, it's a whole lot easier. I go into a subdivision, and what that could mean is an individual septic tank at every house. But what I do is I put the treatment somewhere else, so we can make a green space. So we gather up all that waste, we treat it with on-site systems, and then in a good community, we tend to bring it back for reuse water, so we can do trails and things like that. But you can also do it in these very densely populated areas with existing systems. And so you can go in there, if their septic tanks are still good, you can keep those. Often they're older, and you need to really test them and look at them. You can bring in those septic tanks, and then you can do this decentralized community. And so what happens is now instead of everybody having one on their site, and you're worried about your setbacks for your water, You bring that treatment out, but the thing is, you don't have the transport pipes as far. And so that might be one of those options for you. You've got your septic to sewer plan. They've told you they're not going to get out into this community until here or maybe ever. And so you know you have a densely populated area. This might be where you want to look. And depending on the technology, your footprint can be very small or it could be a larger footprint. And most of this technology can be made load-bearing. And what that means to you is you can get it out of the way as long as you get risers and lids on them that you can get to them. And then you take that drain-filled material, use drip or something like that, and go to your green space. So it gives you the opportunity to add value to your community because you have that green space, but then adds value to your community because you're taking away all your fecal concerns, your nitrogen concerns, and your phosphorus concerns. And it's just something that a lot of people don't think about because they forget that we can go from on-site to clustered systems or to central sewer. It has to be this combination of all three. That's the only way we're going to take care of Florida's wastewater problems. So, now what? You really have to think about what your community needs. Just because somebody's doing it across the street or across the state doesn't necessarily mean that it's going to work for you. You have to, as a community, really sit down and talk. And you have to have some really good, honest communications. And change is hard. Change that costs money is really, really hard. I just gave you a lot of options. So you need to go into communities and look and see what your options are. One size doesn't fit all. You don't want to ever, if one of my manufacturers tells you that their technology is great for everything, not straight out of the box. They might be able to do some different things, but that one straight out of the box is not going to fit for all your needs. And then what you really have to do, and this is where sometimes we get lost, is you have to do an honest, and you see my honest in quotes, cradle to grave. When you start comparing the cost of whether it's a single system, a community system, or a wastewater treatment plant, that true cost is without all the grants, without all the funding. How much is it really going to be for the central sewer? How much is it really going to be for home for the decentralized? How much is it really going to be? And then you go back and you look at what you need and the cost per pound of removal. A lot of times what we see in these costs is we've put in, well, we're getting this much from this grant, this much for this grant, this much for this grant. An innovative thinking community can apply that grant money to upgrading OSTDSs. It doesn't just have to be used for the wastewater treatment plant. That's just what we've always done. Don't be afraid to think outside the box. If you don't do well with thinking outside the box, just change your parameters of your box and you will stay in your box. This is an important topic. I remember 20 plus years ago when I was looking at nitrogen as my PhD project, and the dean of the university said, Roxanne, we will never be talking about nitrogen and on-site systems. Go find something else. I said, I'm from the Chesapeake Bay. It concerns me. I had friends that were watermen, and so it concerned me with what was going on in the Chesapeake Bay, so I did the studies. So, here's my goals. Did I get some kind of response from you? I don't care if I made you angry. I'm okay with you going, why did they invite this lady? We need to sewer the world. Vincent's a really nice guy. But I need you to get a response, because if I get a response from you, you'll start talking. Hopefully I make you think, and then I make you say, if it's been working so well for the last 25 years, why are we in the position we are now? There's nothing wrong with saying we could do better. There doesn't have to be the accompaniment of, and you messed us up. I'm pretty sure none of us rode in here on a horse and buggy, right? Nobody's got the big bag phone, although I think sometimes they work better than our small little computer phones. So, these are the things that, did I make you think? Did I make you question? Did you realize there's more opportunities out there and it's just not about our legacy systems? And then I'll take any questions and comments when we both get up here. And we keep it nice and pleasant, right? Thank you very much.